IntrinsiQ is a world leader in the production of critical components for electronic applications, including heating. In the next few minutes, we're going to introduce you to the IntrinsiQ aluminum heater, a unique new technology for ultra-fast delivery of heat in electronic applications. Heating technologies come in all shapes and sizes and address a lot of different challenges. But one challenge that has been difficult to overcome is the speed with which a heat sink can be brought to operating temperature. That speed can be a critical competitive advantage. Faster warm-up means more productivity for your customers and more sales for you. The problem is multiplied in automated systems, in which temperatures cycle between cool and warm. Faster warm-up means shorter cycles, greater throughput, and higher productivity. Applications that can benefit from this faster warm-up include medical diagnostics, back-end semiconductor tools, analytical instrumentation, telecommunications, and fuel cells. If your application could benefit from faster heating, consider the IntrinsiQ bonded aluminum heatsink assembly from IntrinsiQ. Aluminum is the material of choice for heat sinks. It's affordable, easy to machine, and an excellent conductor of heat. There are a number of ways to heat an aluminum heatsink. The question is, how fast does each work, and what are the trade-offs? Kapton heaters are compact, distribute heat evenly, and can be profiled to compensate for heat loss at the edges of the heatsink. However, Kapton's watt density is limited by its adhesives and a less than 60% heating element coverage. For these reasons, it is not an ideal choice when extreme speed is critical. Cartridge heaters, on the other hand, support high watt density. Inserted into drilled recesses in a heatsink, they can transfer heat quickly to the aluminum. The problem is that it takes a large heatsink to accommodate the cartridges, and increased mass means slower heating. In addition, drilling the aluminum for the cartridges can be costly, and cartridges may not distribute heat uniformly. Thick film heaters also support high watt density, but thick film cannot be applied directly to aluminum. Instead, it is baked onto steel, which is then bolted to the aluminum. Unfortunately, steel is a poor conductor that significantly slows heat transfer. Also, at high heat, steel can warp, slowing heat transfer and reducing uniformity. Mica heaters support high watt density, but mica is fragile and is typically sandwiched between metal plates. This significantly increases the mass that must be heated, which slows heating. Also, mica heaters must be burned in to drive off volatile organics, adding steps to the manufacturing process. IntrinsiQ eliminates all of these problems. The patented alkaline process forms thin dielectric and resistive layers directly on aluminum, eliminating thick film's intermediate steel layer that can warp and slow heat transfer. Unlike cartridge or mica heaters, IntrinsiQ does not require any additional material to accommodate or protect the heating elements. The heatsink can be compact in size, and there is no additional mass to slow warm-up. IntrinsiQ comes manufactured to your specifications, ready to install, and requires no assembly on your part. Bottom line, for shorter warm-up times and maximum throughput, the solution is IntrinsiQ. IntrinsiQ gives you high watt density for faster warm-up, high uniformity for even heat distribution, no intermediate layers to slow heat transfer, thermal profiling capability to compensate for uneven heat loss, up to 100% surface coverage for maximum heat transfer, high bond strength for reliability and long life, and delivery complete and ready to install. By delivering IntrinsiQ ready to install, IntrinsiQ can actually reduce your total cost for heating assembly by 20% or more compared to traditional conductive heaters. IntrinsiQ is based on the patented alkaline process. This process begins with an aluminum heatsink machined to your specifications and sandblasted in preparation for coating. The dielectric layer is applied, then baked directly onto the surface of the heatsink. Baking produces a solidly bonded ceramic layer a fraction of the thickness of a traditional adhered dielectric layer. Conductive bus bars are then applied and baked directly onto the dielectric layer. These low-resistance conductors convey current to the resistive layer. The resistive layer is applied and baked directly onto the surface overlapping the bus bars. This is the heating element that converts current from the bus bars into heat. The individual layers of a finished IntrinsiQ heater measure just thousandths of an inch in thickness. The combined layers of the completed assembly add about 1/100th of an inch on top of the aluminum heatsink. The alkaline process gives IntrinsiQ capabilities no other technology can match: faster heating, compact design, uniformity, thermal profiling, durability, turnkey delivery, and cost savings. For more information and technical specifications, visit IntrinsiQ.com/IntrinsiQ or contact your IntrinsiQ sales representative to find out if IntrinsiQ is right for your application. The Intrinsic Aluminum Heater, only from Minco.